Welcome again to my channel, and today we'll be solving this Leetcode question number 63, which is marked medium, and the name is unique paths 2. So what does the question say? The question basically wants us to find the number of unique paths from start to end that the robot can take without running into any obstacle, right? So let's move to here. So our aim is to start from 0 0 of the grid and move to the end, right? And we have to find all the unique paths possible for this. For this particular example, the unique paths would be this is the first path, and the second path would be this. So the answer here would be 2, right? The answer for this question is 2. Now there are two conditions for the question. One is we cannot run into any obstacle like these ones, right? We cannot do that. And the second one is the unique. The path should be unique, right? So we cannot be like, let's say I move this object out of here. I move this one out of here, and let's say the path I take is like this. So this won't be a unique path, right? Why? Because I have traveled to this box twice. I entered this box, I went away, and then came again to this box. So this is not a unique path, right? So we don't have to worry about this unique condition. Why? Because the question itself states that we can make only two kinds of movement. We can either move right like this, or we can move down. That means if I go into this box, I cannot come back into this box because this movement will be a left movement, right? We cannot make that. The question itself states that we can only move right and we can only move down towards the bottom, right? So that helps us in maintaining the unique condition, right? The second condition is not running into obstacles, which is fairly simple. Before making any movement, we can check that if this cell that we are moving into has a obstacle or not, right? So if it has obstacle, we'll just not move into it. So we'll solve this using recursion. So the first check in the function itself we can check is if the grid, the 0 0 coordinate has an obstacle or not. If the start index itself has an obstacle, we cannot do anything, right? So we'll return 0 in that case. Next, let's find out the lengths of the grid. So length of grid and length of 0, right? So basically m will represent this length, the rows, number of rows, and n will represent the number of columns, right? Let's just write this down. This will be n and this will be m. Okay, and we'll also use indexes to traverse, right? So for that I'll take an I index which will traverse over the rows. So I and M will be for the rows, and for the column I'll take a J index, right? You'll see what I mean, but just keep in mind that whenever we are doing comparisons, we'll have to compare I with M and we'll have to compare J with N, right? So next thing we can check is if obstacle grid of M minus 1 and N minus 1 has an obstacle, right? Then also we cannot do anything, we cannot find any paths, so we'll return 0. By the way, the question, it's marked that if an obstacle is present, then it will have a 1 value in the grid, it will be value 1, and if it does not, it will be 0. So that's why I'm comparing with 1. 1 means obstacle, right? Next, we'll call the solve function. So return solve, and let's write the solve function now. Solve, first we'll get the grid, which is a 2D slice or array, and then the dimensions, and then the current indexes we are on, and we'll return the answer, right? Now, so let's imagine we are here, right, in this box. What will the value of this box? The coordinate, basically. The coordinate of this box will be 1, 2, right? That means this will be the ith index, this will be the j, right? Now, for the recursion, the base case that we want is that we have reached the end. If we have reached the end, we'll return a 1, saying that this is a unique path, so we'll return 1, right? So the base case would be I being equal to M minus 1, because M will be 3, M is the length, right? M is not 2, M will be 3. So I equal to M minus 1 and J equal to M minus 2, representing this box, right? Representing this box. This is 2, 2. So M minus 1 and J minus 1. When we reach that, sorry, not I equal to M minus 1 and J equal to N minus 1. When we reach that, if we reach that, we'll return 1. So the base case will be if I equal to M minus 1 and J equal to N minus 1, we will return 1. Now, if we have not reached this particular box and we are anywhere in any of these box, then we have the option of either moving right or either moving down. So for that, we'll define a directions array, 2D array. So var direction array of int will be equal to this. The first value will be 1, 0. Second value will be 0, 1, right? Again, in this case also, the first value represents I and the second value represents J. So when we are in this state, we are saying add 1 to I and add 0 to J. Let's see what this means. This means, let's say we are in this one, we are saying add 1 to I, that means make 1 to be 2, this one, and add 0 to J. So J remains same, that means we move down, right? And the second state is 0, 1, that means add 1 to 0, add 1 to J. That means let the I be whatever it is, just add 1 to J, that means move right. So we'll iterate over that two conditions for every cell, because in every cell we have the option of either moving left or down, unless we are moving out of the bound, which we'll cover, but every cell has the option of moving right or down. So for D range detection, the new row will be I plus D of 0. As I said, the first value represents the row, and in our case the row is represented by I, so I plus D of 0. New column equal to J plus D of 1. Now we'll have to check conditions of these new row and new column values, which are if new row greater than equal to 0. Of course this condition will be valid all throughout, but just for being explicit, I have given this condition. Then we'll have to check new column greater than equal to 0. This will also be true always, but just for that I've given for being explicit. The important condition is new row should be less than m and new column should be less than n. That means we do not want to go out of bound. We do not want to move out of the grid either this way or that way. We do not want to do that, right? So that's a condition we have to follow. And the last condition would be grid of new row using these new row and new column values. The box that we'll get should not contain 1. That means we do not want to run into an obstacle, right? Let's imagine we are here and we are checking for this box. If there is an obstacle, we do not want to go there. So we have this condition, right? Now we'll call, if every of this condition is met, then that means we are safe to go into that box. So we'll do so. So grid m and m remain same, and I and j will be new row, new column, right? Now this will return 1 if it eventually reaches the last index, right? So we want to use that value. So for that we'll take a variable here saying paths is 0, right? Currently we don't know if there is a path to the end or not, but if there is, what we want to do is paths plus equal to however many paths we get forward from this state onwards, we want to add it to paths and return paths, right? Now we'll call this with the values. So grid m and we'll start with the 0 comma 0 index. So I and j will be 0 and 0. Let's see if this works or not. So this is working, right? Now we need to memoize it so that it does not give us a time limit exceeded error, right? So here, since the only thing in the recursive call changing are these two values, basically I and j, so we can use a 2D array to memoize the recursion, right? So we'll say memo equal to array of int 2D array, and it should be similar to the grid length as well, because for every index we want an answer, right? So m plus 1, it can be m, but just for being extra careful, I've added 1 to the m as well. Now for I range memo of I equal to make array of int of length, again n plus 1, and for j range memo of I, every value in the starting will be -1, right? And we'll pass this to the recursion. We'll accept it here. Then we'll check if a current value exists or not. If memo of ij not equal to -1, that means a answer exists, so we'll return that memo of ij. And if we do solve it, we want to store the answer, right? So memo of ij equal to will be the path. We need to pass the memo here. Let's see if this works or not. Let's try to submit. And this works. So here's the full code again, if you want to pause and write it. That's all for today. Thank you for watching.